All right, and welcome back. In this video, we are going to be talking about how to specifically graph what are called absolute value functions. So please have out your guided notes, and let's begin. So whenever we talk about functions, we have what's called the parent function, which is what we compare any changes that we make to the original. So it's like the OG function. Our absolute value parent function is written as y is equal to the absolute value of x. So we have it listed right here. In your guided notes, it looks like here. And within the actual graph of an absolute value function, the parent function starts at 0, 0, and then it goes up and right and up and left. And you have two straight lines. We can represent these values in a table. If you were to use an input-output table, you input an x value, you get a y value, and you can plot those. When you plot them, you're going to notice that that's our parent function. That's what we're going to be comparing to every single time that we have an absolute value function. Now, the general form for an absolute value function is listed down here. Y is equal to a times the absolute value of x minus h and the absolute value plus k. And there's a lot of letters there. And we're going to talk about what each one of them does. And then eventually when you get to Algebra II, you'll start to really dive in to absolute value functions and how to write them and how to transform them. But for right now, we want to talk about the basics of it, what the general form is, how we utilize it, and how we're going to graph. Now, in your guided notes, I don't think there's a lot of room to write underneath each of the letters, and I apologize for that, but let's see if we can make it work for us. The letter A, the number on the outside of the absolute value, almost attached to the absolute value sign, that is going to tell us how much it's stretching or how much it is widening. So it's going to tell us, are we looking more narrow of a V, or are we going to look more wide of a V? The H within the absolute value. Now, a lot of students mess this up. We have x minus h. It always has to be a minus h. So we're looking at the numerical value of h. That is going to be telling us the horizontal shift. So that's going to be telling us how much we are moving left or how much we are moving right compared to the parent function. And then lastly, we have k. And k tells us the vertical shift. How much we are going to be going up or how much we're going to be going down, again, compared to the parent function. And let's take this general form and let's put it into play. If we were to find the vertex of an absolute value equation, we can utilize that by finding the opposite of h, comma, k. Let's just rewrite what our absolute value looks like. So y is equal to a times the absolute value of x minus h plus, not plus 5, yikes on bikes. All right, plus k. Whoopsie daisy. So when we compare the absolute value function we're provided to our general form, we're going to find a couple of common numbers or common ideas. For number one, we have y is equal to the absolute value of x plus 2, and then we're taking away 3. So in order for us to find the opposite of our h value, if we look inside our absolute value function, it's x plus 2. Well, that's really written as x minus negative 2. So when we look at the vertex of it, we need the opposite of h, comma, k. Well, the opposite of h is currently negative 2, so that means our vertex would have a opposite h value of positive 2. And then our k value is whatever number is on the outside, so 2 minus 3. When we look at problem number 2, we have y is equal to the absolute value of x minus 1. That is in the form that we want it to be in. We have x minus 1, so now we look at the h value, and we take the opposite of it. So that means our vertex, let's do this one in green. The vertex here would then be negative 1, and we don't have a k value on the other side. There isn't one, so it's really plus 0. which means our k would then be 0. For number 3, if we look inside our absolute value, well, we just have x. Again, this is the same thing as x minus 0. Well, we identify our h value, which is 0. Now we take the opposite of it, well, which is still just 0. So our vertex would then be 0, comma, and our k value is plus 4. So 4. And that's how we're going to find the vertex within an absolute value function. Now, you might be saying, why can't I just look at the actual number that's being displayed? You absolutely can. Absolutely can. So in the first one, we had x plus 2. Well, if you notice, plus 2, and then we end up with a positive 2. We had a minus 1 for problem 2, minus 1. And then 0 is just 0. So you can absolutely do that as well. Let's now talk about how we graph knowing how to find the vertex, and let's go through an example. So the steps that we're going to take the graph is the first thing we have to find the vertex. We're then going to create a table to represent the function with the vertex in the middle row, and then we're going to graph some other points. If we look at our absolute value function, we have y is equal to the absolute value of x minus 2. Well, our vertex is the opposite of our h. Well, it's 0 inside, which is great. And then our k value, so minus 2. So we're going to plot 0, minus 2. We're going to place this vertex in the middle row, because the vertex tells us like the middle point. So we had 0, and we had minus 2. Now we're going to choose a couple x values that are smaller than our x value of the vertex, and choose a couple x values bigger than the x value of our vertex. So smaller, we'd go like -1, -2, and we can plug them in. If we substitute -2 into our absolute value function, well, the absolute value of -2 is 2, and then 2 minus 2 is 0. So we end up with -2, comma 0. -2, comma 0. When we substitute in the x value of -1 into our absolute value sign, we have the absolute value of -1, which is positive 1. Now positive 1 minus 2 is then -1. So we're now going to plot -1, comma -1. Let's use red. We can continue the pattern. We want to kind of stay close to our vertex whenever we can. We have the x value of 1. We substitute it in. Absolute value of 1 is 1. Well, 1 minus 2 is -1. So we can plot 1, comma -1. We can substitute 2 into our absolute value equation. Well, the absolute value of 2 is 2. 2 minus 2 is then 0. So we can now plot 2, comma 0. Now that we have our points, we can draw our lines to the best of our ability in here. Very good. And that's how you graph a absolute value function. Now, if we want to bring it back to that parent function in terms of comparing, right? So our parent, it's y is equal to the absolute value of x. In green, it looks like this. Our vertex is 0, 0. And we grow this way. I'm about to talk to you about a high-level skill that you eventually are going to get. If we look at our parent function in green that's graphed, and we look at the absolute value that we graphed in black with the black lines, well, what's the difference? They seem to be growing at the same rate because they're not really touching at all, but they're above and below each other. Like if we were to take a peek at, what color are I going to use? Let's go, yellow isn't going to be my friend right now. Let's just look at, I don't know, blue, why not? If we look at the green point and the red point, or the green point and the blue point, or the green point and the purple point, we can see there's a distance here of 2. There's this distance of 2. And you don't need to graph this, by the way. A distance of 2. Well, in our absolute value function, we had a k value of -2, meaning we had a vertical shift 2 down. So every time we're comparing to the parent function, to our current equation, well, it's going to be 2 lower than what we should normally expect. And that's how we can eventually utilize the a, the h, and the k values, which again, we'll get to eventually, whether this year or when you get to Algebra 2. But that's how everything kind of comes together. What I need you to be able to do is to find the vertex and then create a table to then plot 5 points. If you can plot 5 points and get the general gist of what the absolute value function is showing, for me, that's going to show a lot of success. With that in mind, please continue on through, come on now, please work through problems 4 through 6 on your own. You're doing a fantastic job. This is not the easiest thing in the world, but you are attacking this with an amazing amount of effort, and you should be very proud of yourself. So with that, again, please work on problems 4 through 6 on your own. Keep making yourself proud. Let me know if you have any questions. I'll talk to you soon.